So this is actually 7.5 day 2. This is where we kind of cut it off. So we're going to talk about the quotient property of radicals. So basically what's happening here is if you have a fraction underneath a radical, you can split it up into the radical of the numerator and then the radical of the denominator. Now, basically what's happening here is we're just going to focus on square roots here. We're not going to get into the ones that are not square roots. It gets way more complicated once you throw those in, and it's just not a necessity at this moment. So basically what's happening is you're always just going to end up multiplying by that root. It's kind of like when we had imaginary numbers down there, we would multiply by those imaginary numbers. Okay, now, if you were to do this with ones without it, so looking at 21, we're going to end up multiplying by the square root of x and the square root of x, because then you're ending up with the square root of x squared, which square root and squareds cancel, which is why you'd be left with just x there. So your final answer would be there. Okay, now, again, we're not going to focus on these, and I'll change all the ones down here. But if I wanted that down here, I would have to multiply by x squared, because then we would have the third root of x to the third, which would cancel it. So you'd have the third root of x squared over x. Okay, now again, we're not going to go that route. We're just going to focus on the square roots. Okay, so again, all of these, we're going to pretend like these are all square roots. So the first thing we're going to do is we're going to split it, the square root of 5 and then the square root of 4x. So if I want to get rid of the square root, because I can't have a radical in the denominator, I'm going to multiply top and bottom by that root. Okay, so we have the square root of 5 times the square root of 4x, which becomes the square root of 20x. And the square root of 4x times the square root of 4x. Now this technically becomes the square root of 16x squared. But then you can simplify it. The square root of 16 is 4. The square root of x squared is x. Notice it went root 4x, and then we just had 4x. That's always going to be the case, and that's what we'll do from here on out. Now, we have the square root of 20 to break down. We have 4 times 5, 2 times 2. So that can be rewritten as 2 and then root 5x. Now, hopefully we're noticing 2 over 4 can reduce. So we get the square root of 5x over 2x. Okay, again, the x's cannot be simplified because one is on the inside and one is on the outside. So the next one, we're going to start the same way. Square root of 3, square root of 4, y squared. Now, maybe you noticed it on the last one, but technically what we could do is take the root right now, right? I know the square root of 4 is 2, and I know the square root of y squared is y. So we actually didn't have to do much work here because it's out of the denominator now. On the last one, we have the square root of x to the 6th over the square root of y to the 7th. So I'm going to multiply by the square root of y to the 7th in the numerator and denominator. So our numerator becomes x to the 6th, y to the 7th, and then our denominator would just be y to the 7th. Remember, it always just cancels it. And then we have to simplify. The square root of x to the 6th would give me x squared. And then the square root of y to the 7th, we have to break down into y to the 6th and then the square root of y to the 1st, which gives me y to the 3rd and then the square root of y. Okay, I wrote this wrong. This is supposed to be 3. So we have y to the 3rd over the square root of y, and then we have it over y to the 7th. Hopefully we see. We need to simplify this. Remember, when it's fractions, we need to subtract the exponents. So 7 minus 3 is 4, and it goes where the larger one's at. So we have x to the third square root of y over y to the fourth. So that's our big thing. I'm going to have you try a couple on your own. We are not going to do the conjugates that are down here. We are just going to focus on these ones. Okay, so go ahead and try these and then I'll go over it. For number 26, we're going to multiply numerator and denominator by b to the fifth, the square root of b to the fifth. So we get the square root of a to the ninth, b to the fifth over b to the fifth. Simplify our numerator. Square root of a to the ninth, I would have to break it down into a to the eighth times a, which gives me a to the fourth root a. And then the same thing with b to the fifth. I need b to the fourth and then b, which gives me b squared root b. So if we write that out, we would end up getting a to the fourth, b squared, square root of ab over b to the fifth, which then needs to simplify with our b squared. Subtract them, we get 3 in the denominator because that's where the larger one's at. All right, and the last one, hopefully we remember to get rid of the 4 on the outside. This becomes the square root of 6 over the square root of 5x squared. And maybe you noticed it, but we can make that x square root of 5 to start. So then all I'm really needing to get out is the square root of 5. If you didn't do that, you just have more simplifying to do later. So we get the square root of 30 over the square root of, or not the square root, over 5x, because root 5 is 5. And if we take 30 and try to break it down, 3 times 10, 2 times 5, there are no pairs, so it has to stay just like that. Right? And that's the focus of today.